Hello everyone. In this lecture, we will be looking at refactoring. There are two reading materials, Refactoring, Improving the Design of the Existing Code by Martin Fowler, and Refactoring to Patterns. So looking at how this business of refactoring started, say for example, you have a code base and you add changes to this code base daily. So you add a small change today, you do the same tomorrow and the day after. But if you don't keep a mechanism of properly tracking the changes and keeping a record of what each change does and what each code segment does, then it's going to be a bit of a hectic process to find your way around this code base in a couple of months or in about a year. It doesn't affect you for a few days, but when you try to find your way around in months or years, it's going to be hectic and it's going to be a spaghetti code. So when you have new changes being introduced to the code base regularly, eventually your code base is going to be in one of the two states, rewritten or abandoned. Rewritten state means nothing from the original code is there anymore in the code base. Abandoned means the original code is thrown out and it's being rewritten from scratch. So the original code is abandoned rather. So the systems evolve to meet new changes and they add new features. But if the code structure, the code base also does not evolve with the system evolvement, then the code base will rot, we say. Therefore, we introduce something called code maintenance. So code maintenance means modification or repair of a software product once it has been delivered. So the purpose of maintenance, as you know, is to maybe to fix bugs or to improve the performance of the design. Maybe you need to add new features to the system. So when it comes to maintenance, there are 4 types in which you can do this. You have preventive, operational, corrective, and adaptive maintenance. The first one, preventive maintenance, means the equipment is maintained before the breakdown occurs. So you are taking preventive measures in this case. Before the breakdown happens, you will take precautions to make it not happen. Operational maintenance means equipment is maintained while you use it. You're using your system or the code base. While you do so, you're trying to maintain it. Corrective means you do the maintenance once the breakdown has occurred. So you wait until everything is not working and then you do the maintenance. So this is quite costly because then you have to repair the worn out equipment. Yeah, they are damaged now. There are multiple renovations to do. Therefore, this is the most expensive type of maintenance. Finally, adaptive maintenance means you let your system or the code base or equipment to adapt to new changes. You know change is coming. The environment is going to get modified. knowing that you will prepare your code base of the system to adapt to this new change. So maintenance is not an easy task. Writing your own code is quite easy. It's easier than maintaining somebody else's code. Because in that case, you need to understand the code written by the other developer. You need to understand his thought process. And most developers don't actually like the maintenance part of it. Plus, usually it's what takes most of the time. The thing is, even though it's a pain in the head, the design of the software is preserved and a well understandable system is produced through maintenance. So what does refactoring do? Refactoring improves a piece of software from the internal structure without altering the external look and feel. So the internal structure will be more comprehensible, more understandable through refactoring, but the outward look, external behavior rather, does not change. So refactoring takes less time and less cost. And it's a long-term investment for the overall quality of the system. So remember that refactoring is different from adding a feature or debugging a code or rewriting the code. Refactoring is a separate business. It's different from these three. Don't assume or don't take the idea that they're the same things. Adding a feature is different to refactoring. Debugging and rewriting is also different to refactoring. So this is controlled. Refactoring is a controlled technique to improve the design of a code base that you already have. So what we do in refactoring is we introduce or we apply a set of behavior preserving changes. So in general English, we say that each change, each transformation we introduce or apply to the code base is too small to be worth doing. Okay, but collectively, when you take all the changes you do as a collection, it's worth doing, right? So when you do these changes in small steps, you reduce the risk of introducing errors to your database, code base. Plus, on the other hand, you avoid the system getting broken down while you're carrying out the restructuring. And when you do it in small steps, you can preserve the external behavior because you're only modifying or adjusting the internal behavior, the internal structure rather. So when you do it in small steps, you can assure that the external behavior stays the same. It doesn't change. So the process of changing a software system in a way that it does not alter the external behavior of the code, but improves the internal structure is called refactoring, according to the Fowler's book. So remember that when you modify or improve the internal structure of the code, it improves the readability, understandability, maintainability, extendability. All of these are improved So remember that the goal of refactoring is not to add new features or rewrite the code or anything of that sort. It's just to improve the structure of your internal code. So remember that refactoring is a separate thing. It's not aligned to adding new features or anything of that sort. It's just to make the internal structure clean and understandable so that it's easy for maintenance in the future. So you rearrange the code in refactoring, and you do this in small steps to preserve the external behavior. So your transformations are too small to be worth doing. Each single transformation is too small to be worth doing, but when you accumulate all the changes, it's actually worth doing. And you do this to make your code base understandable and readable, extensible, and easy to maintain in the future. So when you refactor, you need to assure that the code works, your system doesn't break down, and the external behavior is not modified. So looking at Fowler's definitions, he says that refactoring is the process of changing a software system in a way that it does not alter the external behavior, but improves the internal structure to make it easier to understand and cheaper to modify. Kent says that it is the process of taking a running program and adding to its value by not changing its behavior, but giving it more of these qualities that enable us to continue developing at speed. So it's more or less the same thing said in two different ways. Okay, so let's look at an example. So when you move a method, first of all, a method is using or used by one or more features of another class than the class in which it is defined. Okay, so that's the motivation of the example. So what do? We create a new method with a similar body in the class, similar details in the class. And then we either turn the old method into a delegation or we remove it. So why, taking from the example, why do we usually do refactoring? That's because we want to remove duplication, we want to improve communication and comprehension of the program, understandability. We want to add simplicity plus flexibility. So refactoring is like a new kind of relationship with your program. When you really understand refactoring, the design of the system is fluid and moldable to you as the individual character in a source code file. When you look at the code base, you will be able to understand the design at once. You don't have to read through the lines of the code. The new structure that you introduce through refactoring is going to give you clear visibility through to the design of the code base. And if there are any possible changes to be introduced, you can identify where the change should go. So basically, the code base becomes quite clear and comprehensible. So we take a metaphor with refactoring as health. So if we take it as health, exercises and eating a proper diet, so what happens here is we can make excuses and not do our daily exercises. We can continue to ignore this good lifestyle. It might not affect us in the short term, but in the long term, it's not going to give us good benefits. Refactoring is also the same. We can ignore maintaining a proper structure in the internal code base for the short term, but in the long term, it's not going to be easy for the developer. You might not be able to find your way around the code, and it's going to be a spaghetti code, basically. So there are dangers as well, because refactoring can introduce problems as a possibility. Because anytime you modify your software, you may introduce bugs. So refactoring might add risk. Plus, it could be expensive as well. But we still do this. Plus, your code base, which might have been fully tested before, is not tested once you refactor it, because you have changed the code base. And if it was well commented before, now the comments may not apply. And if the code was fully reviewed earlier, once you do the refactoring, it's not reviewed. And even if a small change that you had introduced in the initial part of the refactoring process may have a large chance of generating an error in the system. So we say easy to insert a bug into previously working code. So the code was fine before you refactored, but once you did refactor, there could be a bug, which we say regression. So what does regression mean? What if refactoring introduced a new bug in the system which was working fine before refactoring? So how can we avoid this? Well, when you introduce changes through refactoring, you need to do unit tests plus system integration tests as well. Yeah. So before you confirm the change, you need to run the test and see whether the code still works. So there are ways in which you can make refactoring safe. You can always use refactoring patterns. In Fowler's book, he assigns names to refactorings what we will see in the upcoming slides. So you can use a pattern for refactoring, which is safer. Then the next thing that you can always do, which is obvious, you test. You test before you write the code. Sorry, you write the test before you write the code. So each refactoring change you introduce, you test it. So it gives you the space to modify or fix the problem before you move on. We refactor because we want to understand the design of the code base the first time we look at it. Yeah. So probably the code size of the code base would reduce after refactoring. Confusing code will be restructured into simpler code, so it will be comprehensible. Therefore, the maintainability of the system would increase. So refactoring eventually increases or improves the design of the software. Plus, it will be easy to understand. When you look at the code base itself, you'll be able to get an understanding of the design. And you can easily find bugs. And also you can program or develop. You can do the rest of the development faster than how you have been doing it this far. It's quite hard, quite difficult to get the design of the system right at the very first time. And it's hard to understand the problem domain. User requirements, you must have learned in previous software engineering subjects that getting user requirements right at one go is one of the hardest things. Plus, it's a bit unclear how the system would change in the coming 5 years. So it might not be possible for you to plan ahead, plan for change. Also, when it comes to the original design of the system, it might not be adequate to support change or to support the big picture of the system, which may not have been delivered to you at the first time. So refactoring comes in to help in this case because it can manipulate code in a safe environment. Safe environment as in the behavior, external behavior doesn't change, so it's safe. Plus, it lets evolution be possible. And you can easily understand the existing code. When you add a function, it helps you to understand the code you're modifying. And when you need to fix a bug, when you get a bug report, that's a sign the code needs refactoring because the code was not clear enough for you to see the bug in the first place. And when you do a code review, it helps you to spread knowledge through the development team. And code reviews works best in small groups. You should refactor when you see a better way to do this, the things in the code base. And you can do so without breaking down the system. But in a case where your code is quite stable, plus if it is someone else's code, then it's better off to stay away from refactoring. How do you schedule refactoring? Well, it is something that you do all the time in chunks, in small chunks. You don't schedule a time saying, okay, this is when I'm going to do the refactoring. No, you do it as an ongoing process. But you don't decide to refactor if your code is just fine and understandable. There's a rule of 3 which we adhere to. The first time you do something, you just do it. You know nothing about it, you have no prior experience, so you just do it and see how it goes. The second time you do something similar, you wince at the duplication, but you do the duplicate thing anyway. As in, the second time you do the same thing, you know how you did the first time, so you're not fully agreeing with the way you did it. You kind of are not voluntary or involuntary to do it in the same way as the first time, but you do it in the same way anyway, in a duplicate way. Then the third time you do something similar, you will refactor. So what are the signs that tell you that you need to refactor? Well, your code is duplicated, it's too long and deeply nested, poor cohesion and there's coupling, and then there are too many parameters, and there are weak subclasses, unused code, etc. So the traditional software engineering is modeled after traditional engineering practices. You first design and then you code. So the assumptions you make are the desired end product can be determined in advance, meaning you design first. But the agile software engineering has different assumptions. They say that requirements change as users become acquainted with the software. Therefore, programmers and professionals who have varying skills and knowledge are in the best position for making design decisions. Refactoring, we say, is fundamental to agile programming. It's necessary in a traditional process when the design is flawed. Refactoring has properties where it preserves correctness. You take one step at a time and you do frequent testing. And the attributes for design of abstraction, flexibility, and clarity. So how do you refactor? This is accomplished by building, decomposing, and moving methods. Or building and decomposing clauses, or replacing code with patterns and replacing code with other techniques. So Pareto analysis helps to identify heavily used or time-consuming code. Then refactoring begins by designing a solid set of tests for the section of code under analysis. Then you identify problems in a given particular code by reviewing it using code smells. Let's see what code smells are. Once you do that, you introduce refactoring and you test. When you refactor, remember to save, backup, and checking the code before you mess with it. You need to write unit tests, plus analyze the code to decide the risk and benefits of refactoring. Then you refactor the code, you review the code, and you check in the refactored code. There are 3 types of refactoring: class, method, and attribute. In class refactoring, you can add a class or subclass to a hierarchy. You can rename a class or remove a class. In method refactoring, you can add method to a class, rename a method, remove, push down, push method up, add parameters, extract codes in new methods. And in attribute refactorings, you add variables to classes. Rename a variable, remove a variable, push down, push up, create accessors, and abstract variables. So you refactor design patterns, or you can rename, you can extract, you can split one method into several methods, you can change method signatures, you can improve optimization. Here we have the refactoring patterns, which we spoke about in the previous slide. So as you can see, there are many patterns. Under several headings, you have composing methods, moving features, organizing data, simplifying conditional expressions, making method calls, dealing with generalization, and big refactoring. So these are the refactoring patterns available. To identify the code that you need to refactor, you can use code smells. Like we mentioned in the previous slide, you do code smellings and you identify the problematic code segment. So what's the code smell? Code smells are bad things or wrong things done in a code. Something like a bad patterns in a code. You use code smells and refactoring as techniques to help you discover problems in the code design and implementation. Code smells are duplicate codes, long method, large clause, lazy clause, divergent change. Likewise, there are many code smells that you can use to identify a problematic segment of code. So duplicate code means you modify one instance of a duplicate code, but not the others. If you do this, that means you have introduced a bug. So this is why duplicate codes become a code smell. And then long method means the method is more difficult to understand. So you need to decompose the conditions, replace them with query, etc. Large class is the class has too much work to do. Therefore, it becomes a problem or a code smell. So what you need to do is to subclass it or extract. Long parameter list is hard to understand and it becomes inconsistent. Therefore, you replace the parameters with methods. Then you have lazy class. Here, the class no longer pays its way. As in, maybe the class was downsized. or represented planned functionality that did not happen. Then speculative generality means you think you will need to do this someday. You speculate. It's not something you need at the moment though. Temporary field means an attribute of an object is only set in certain circumstances, but an object should need all of its attributes. But you are not using it everywhere. You're only using it in certain situations. Data class means there are classes that have fields, get set methods and nothing else. They are data holders. But if it is an object, it should be about data and behavior. Then comments could be a code smell. Why? Because sometimes they're used to hide bad code. Shotgun surgery. The situation occurs when every time you make a change, you have to make a lot of changes to a lot of different classes. So what you need to do is you can move the method or the field where you're making the change and bring out a whole bunch of behavior together. Then when you make a change, you don't have to go everywhere in the code making the same change everywhere. Then we have feature envy. It's a method that seems more interested in a class than in a class than the one that it is in at the moment. It seems more interested in a class in some other class than the one that it's in. So what you need to do is move method or extract it and send it to where it is more interested in. Then likewise, there are many code smells like we saw in the in a previous slide. So you can go to this link and read about all of them. Eclipse and certain other IDEs as well provide support for refactoring. Well, even though refactoring takes time and the developer doesn't like to do it, it's something you have to do for rapid development. So developers are reluctant to develop a refactor rather, because every time you refactor, tests should pass. The code has to be reviewed. Everything you did before has to be done again. Yeah. Sometimes the developer may not even understand how to refactor. And then the organization itself, such as small companies, don't do it because they can't afford it. But in reality, refactoring is actually an investment. So if you have a small refactor to do, then you just do it. If it is a medium refactor, well, possibly you will have to get the tech lead and another developer also into it. And if the refactoring is a large one, then you need to meet with your team and brainstorm this. Do a design document, review the design. Then you need to get approval before you begin the refactor. Since this is a large one, it's going to create large changes in your code base. Therefore, you need to get prior approval and brainstorm ideas before you do it. Then probably you can avoid possible bad scenarios. You have something called phased refactoring. When the refactoring is too big to do at once, you do it in a phased manner. That means you add a layer of abstraction on top of legacy code. You have a new system on top of poorly made old system. So this old system remains, just direct access. The new system forwards the calls down to system 1 to achieve the tasks. But with time, calls to the old system are replaced by the new system code, providing the same functionality in a better design and speed. So this is called phased refactoring. Refactoring is also a part of extreme programming. When refactoring is part of extreme programming, it becomes part of the routine. It stops feeling like an overhead. So this is a figure from the XP book, Extreme Programming Explained, where Beck talks about the practices that support each other: extreme programming and refactoring. Well, when it comes to cost of refactoring, the environment and the language depends on how well the operations of the source code are supported. Testing. Refactoring heavily relies on testing after each small step. Documentation. All documentation concerning the refactoring and the issue must be updated. So this is an example refactoring to introduce null objects. You have many checks for null. This is the motivation. Therefore, what do? You replace the null values with a null object. So when you have too many null values, that's duplicate and the process becomes tedious. Therefore, you replace the value with an object in the given example. So here, as you can see, you have customer. You introduce this new object called null customer. So you eliminate the if condition. If the customer is null, this condition is fully eliminated, and you replace a check for null with the null object. Here you have a check to see if the customer is null. But here what you do is you eliminate that if condition, entire chunk, and you introduce a check to see if a check with respect to the null object. So it works in the same way. So here you can see an example for a polymorphism. The motivation is you have a condition that chooses different behaviors depending on the type of an object. So what do? You move each leg of the condition to an overriding method in a subclass. And you make the original method an abstract method. So as you can see, you have each conditional case, European, African, Norwegian, blue. So you move each of these conditions to a method in the subclass. And you make the original method an abstract one. So as you can see here, you have the original method bird, and then you push the conditions to overriding methods as subclasses. When it comes to switch statements, these are quite rare in a properly refactored design. Therefore, when you have a switch, this is a code smell, a bad smell. Well, not all switches are bad. It's just that the switch should not be used to differentiate between objects. So for example, here you have different objects differentiated with the switch statement. So what do? You have mammal, bird, reptile. So what do you do to improve it? You're going to replace the conditions with polymorphism. The switch statement, you remove the switch and you replace it with polymorphism. So when you have several objects differentiated through switch, you're going to remove it for improvement. So how does this become an improvement? Adding a new animal type as amphibian does not require revising and recompiling existing code. Mammals, birds, reptiles are likely to differ from each other in other ways as well. So in case if we come across those ways, we've already separated them now. So we don't need to use any more switches. So we have gotten rid of the flags we needed to tell. We needed to tell one kind of animal from the other. We wanted to differentiate one animal from the other, so we used switches. But in case if there are any other ways in which they differentiate, we don't have to use any more switch statements. Why now? Because we have separated them out in this improvement we made through polymorphism. So what we're doing now is we're using objects the way they were meant to be used. So when you have a code fragment that can be grouped together, you turn the fragment into a method whose name explains the purpose of the method. So this is called extract method, and this is one of the most common refactorings. When you have a method that is too long, you turn that code into a fragment of code. You turn that code into its own method. So as you can see here, before refactoring, you have on your left hand side more lines found in a method, and then after refactoring you make it its own method. Then you have split temporary variable. Here you have a temporary variable assigned more than once, but not in a loop. So what you do is you make it a separate temporary variable for each assignment, as you can see here. You have this temporary variable, which has been assigned, which has been used more than once, but not in a loop. Okay. So what do? You make a separate variable for each of the assignments. For example, in the first one, you use temp in the first line of code and the third. But when it comes to after refactoring, you don't reuse it like that. You make a separate variable for each assignment. In the first case, it's perimeter. In the second case, it's double area. And then when you remove assignments to parameters, the code is assigned to a parameter. You use a temporary variable in this case. Without using input val itself, you use temporary variable called result to get your value. Then we come to move field. So move method, the motivation for this is move methods is quite common in refactoring. So move methods, you move methods when classes have too much behavior or when classes are collaborating too much. We discussed a similar example in a previous slide as well. And when they are highly coupled, by moving the method around, you can make the class simple. Move field is used when the field is used by another class, one or more classes. So you create a new field in the target class and change its uses. In extract class, you have one class doing the work that should be done by two. So what do? You create a new class and separate the work among the two classes. Then we have inline clause. This means the class isn't doing that much. So what do? You do the reverse of extract class. The reverse of this is inline clause. When he doesn't do much, you combine, merge two classes together. Then you remove a middleman. This means a class does too much of simple delegation. The main class delegates to some other class, that class delegates to another. So what you do is you remove the middleman, get the client to call the delegates directly. So person and department directly call the client class rather than client class calling person and then person calling the department. Local extensions mean a server class you are using needs additional methods, but you can't modify the class. So you create a new class that contains the extra methods, and then you create an extension from this class, as in you make this subclass an extension or a wrapper of the original. So the motivation to introduce a local extension is when you need additional methods that are not previously defined. But the thing is, if you can modify the source, the best thing is to go ahead and do so. But if you can't modify the source, then you have to refactor. If it's just one or two methods that you need, then you can introduce a foreign method. But when you go beyond, then things seem to get out of hand. So you need to group the methods together and create an extension class. Then we have self-encapsulated field. Here we have get and set methods for the field, and they are used only and use only those to access the field. Then replacing array with objects, you have an array in which certain elements mean different things. You replace the array with an object that has a field. There's a field for each element. So these three lines of code after refactoring would look like this when you replace the arrays with an object. So here, as you can see, this line of code, after you refactor, you're using the variable, you assign the value to a variable at the beginning rather than just using the value. You create a constant in that case. Encapsulated field, meaning if there's a public field, you make it private and provide accesses. Then decompose conditional, meaning you have a complicated conditional statement, as an if then else statement. You extract methods from the condition. So if you look at this, you have the if statement here. So after refactoring, you are going to extract methods. You extract the method, then what happens if the condition is true and the else part. Here you have a sequence of conditional tests with the same result. If that is the case, you combine all of them into a single condition. When all of these three things happen, you return 0. So you combine all of them together. The same fragment of code is in all branches. Move it outside. So all the branches have the same code segment. If that is the case, you're going to move that part of the code outside. Here you have send in both parts. It's not necessary because it's going to happen anyways, therefore you take it out. Renaming a method when the method doesn't reveal its purpose, you rename the method. When you have a method that returns a value but also changes the state of an object, you create two methods, one for the query, one for the modification. You don't do both in the same one. Then parameterized method means when several methods do similar things, but with different values. You create a method, you create one method that uses a parameter for the different values rather than creating several methods to do the same thing. You create one method, one common method, and use a parameter for the differing values. Hide method, a method that is not supposed to be in any of the classes. So you make the method a private one. Then pull up field means when two subclasses have the same field, you move the field to the superclass. So both salesman and engineer has name. So you take it up to the employee. That's pull up. Push down means the opposite of this. The superclass's behavior is only relevant to some of the subclasses. Get quota is only relevant to salesman and not to engineer. In that case, you can't keep it in your superclass, so you take it down to salesman. Since it's not common to all the classes, you can't keep it in the superclass. Extract subclass. Here the class has features that are not used in some of the instances. So you create a subclass for that subset of features. You take the methods that are not in use and create a separate class for that. Then in extract a superclass, you have two classes with similar features. So you create a superclass and move the common ones there. Get annual cost and get name are common to both department and employee. Therefore, you take them up to the superclass party. Collapse hierarchy means when a superclass and a subclass are not very different, you merge them together because there's no point in keeping an inheritance of that sort. So as we mentioned in the very first slide, there are resources and books that you can refer to with respect to refactoring. This is some of the links you can access. So that's the end of the lecture. We briefly looked at refactoring, the techniques, patterns we can use, code smells, etc. You can read more and gain knowledge as well. So I'll meet you in the next lecture.